All right, so this is question number 10, January 2019. A says three matrices are given as follows. So these are three matrices. It says using a calculation method, using a calculation to support, your answer, explain whether matrix P is singular or a non-singular matrix. Well, guys, if a matrix is singular, its determinant is equal to 0. So let's find the determinant of P. So P is the matrix -1, 2, 0, 5. The determinant of P, it's going to be -1 times 5 -2 times 0. So this is -5 -0. The answer here is -5. So since the determinant of P is not equal to 0, P is a non-singular matrix. All right, so for P to be singular, the determinant of P had to be 0. So once the determinant of P is not 0, P is a non-singular matrix. Let's turn the page. Where it says, given that now PQ is equal to R, we're asked to determine the values of what? A and B. So PQ, what is it again? -1, 5, 2, 0. One of my memory is that good. Well, it's only 4 numbers. I celebrate. All right. Q is what? AB. All right, apparently not that well because I don't remember R. R now is 11, 15. 11, 15. All right, there's actually 2 ways to do this, but I think that this is the easier approach. We're solving a matrix equation. We're going to solve the matrix equation. PQ is equal to B. Now, in this case, not B, R. Now, to solve a matrix equation of this form, we're going to write back the matrix Q and multiply the right-hand side by P inverse. All right, so this is something that we have already discussed, that to solve a matrix equation of the form PQ is equal to R, we're going to write back Q and multiply the right-hand side R by P inverse. So let's find P inverse. Now P inverse is equal to 1 over the determinant of P times adjoint P. Now the determinant of P we already know, so P inverse is 1 over -5 adjoint P. We're going to switch these around. 5 minus 1. These two stay where they are, but their signs change to -2, 0. So that's P inverse. So to solve our equation, we're going to write back Q. Q is the matrix with unknown elements A, B. And this is equal to P inverse, which is what? 1 over -5. 5 minus 2, 0, -1. And we're multiplying this by R, which is 11, 15. Let's multiply the two matrices first, then multiply by 1 over -5. Multiply a row by a column. First element in the row, first element in the column. So 5 times 11 is 55. Second element in the row times the second element in the column, -2 times 15 is -30. Bottom row, First element in the row, first element in the column, 0 times 11 is 0. Second element in the row times the second element in the column, minus 1 times 15 is minus 15. So what we have is A, B is equal to minus 1 over 5 multiplied by, this is 25, and down by the bottom, minus 15. Ladies, gentlemen, multiplying by 1 over minus 5 is the same as saying divide by minus 5. So this is 25 divide by minus 5, and this is minus 15 divide by minus 5. So this is going to work out to be minus 5 at the top. 25 divided by 5 is 5. Minus 15 divided by minus 5 is positive 3. So this means that A is equal to minus 5 and B is equal to 3. All right, this is matrices. Next, we're asked to state the reason why the matrix product QP is not possible. Well, Q is a 2 by 1 matrix, 2 by 1 matrix. It has 2 rows and 1 column. P is a 2 by 2 matrix. It has 2 rows and 2 columns. Now, 2 matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. The number of columns in the first matrix is what? 1. The number of rows in the second matrix is what? 2. So QP is not possible because QP is not compatible for matrix multiplication. All right, and if you want to spell it out, the number of columns in the first, the number of columns in the first is not equal to the number of rows in the second. Turning the page. All right, and this brings us now to a vector question. This says OABC is a parallelogram. X is the midpoint of AB. So it's OABC, OABC is a parallelogram. X is the middle of what? BC, and X is the middle of AB, and Y is the middle of BC. The vector OA is the vector R, and OC is the vector S. So remember, a vector can be represented as a common letter, or a vector can be represented as a column vector. So we're to complete the diagram below to represent all the information given above. So just by putting in these letters and points and arrows, we get 3 marks. Then given that OX plus the vector OX plus the vector OY is K into R plus S, where K is a constant, using a vector method, we need to find the value of K. So let's find the vector OX and the vector OY, and then add them together. All right, so this is the vector OX and the vector OY. So using the triangle law of vectors, OX would be equal to OA plus AX. That's the vector OX. Now, please bear in mind that AX is equal to a half of AB because X is in the middle of AB, and AB is the same as the vector what? OC, sorry, is the same as the vector OC, which is what? S. So the vector AX is a half of S. So this is going to be OA, which is R, plus AX, which is a half of what? S. Now let's find OY. Now OY would be equal to OC plus CY. Now CY is a half of CB, and CB is the same as OA, which is R. So CY is a half of R. So this is equal to S plus a half of R. So now OX plus OY is equal to OX, SX is R plus a half S, and OY is S plus a half R. So R plus a half R is 1.5 R. So this is 1.5 R. Now S plus half S is 1.5 S. So this is 1.5 R plus S. And we were told earlier that this is equal to K into R plus S. So if these two things are equal, it means therefore that K is equal to 1.5, or we can say K is equal to 3/2.